Hi, I'm going to be walking through our COVID-19 collection. This collection is a series of images of patients with one of four conditions: bacterial pneumonia, COVID, healthy and viral pneumonia. This collection demonstrates how Zegami can be used to explore these datasets and to get a good overview of a machine learning model that you may have trained. For a quick overview of some of the things you can do with Zegami, we can choose to overlay a colour representing some part of the data that each of these images may have associated with it. So we can grab the condition and we can really quickly see the distribution here of the different conditions. We can swap over to graph view if we want and see that we've got the same number in each category. If we go over to scatter view, we can view a cluster map that Zegami has generated based on the features that a trained neural net have produced after we've fed all of these images through that net. It's quite interesting to use this technique because you can see roughly how the model is perceiving all these different images, and what you would want is for everything of one class to be grouped together, because that would show the model is successfully trying to doing a good job of differentiating different classes from each other. We can see over here that there are these healthy images in green, pretty much all put in the same region on this map. However, there's a lot more confusion between the COVID, viral pneumonia and bacterial pneumonia classes. Before we go on, it's worth noting that there are several different views available for your data. This is just a scatter view of our clustering algorithm, but you could map any parameter that you have available to anything else and see how they stack up. We have map view, so if there's a geolocation associated with each image, then we can render them on a map. So if we jump back over to grid view, what we want to do is try and get an idea as to why the healthy ones are being so clearly distinguished as opposed to the other classes. So if we take a look here, these green ones were the healthy ones, and if we take this colour down, you can quite clearly see with your eye that there is a difference between these and the others, and it looks like it's more of a framing issue, that these images were maybe taken in a slightly different setting or different position, different background. So we can explore that a little bit more thoroughly. A really useful technique to use is to pass images through what's known as GradCam. So this collection here, these are the exact same images, they've got the same data, we can apply the same overlays and filters and graphs to them, but these images have been fed through GradCam, which essentially means that the regions that are warm here are the ones which caused the most activation when being passed through the neural net. So these areas were kind of most keenly focused on and had the most sway when the model was making its decision as to which class it decided that this image would fit into. So what we would ideally like to see is all of the content in the lungs being lit up, because that would show that the model was actively paying attention to the features where COVID would actually start causing an effect, rather than in the skeleton here, or the framing, or these little annotation markers. This is particularly bad. So if we go back and overlay the colour of the condition over all of these, we can see that there's a lot of darkness in the healthy ones, and that gives us a bit of a clue that there may be some kind of bias. So if we zoom in and take a look at a lot of these in aggregate, we can actually see that all of these healthy ones have this little R annotation on them. This is just a dead giveaway that there's a huge bias in this training set. So the model is learning to associate the little R, just indicating the right side of the person, with healthy, because obviously there were the healthy clips were taken from some kind of setting or hospital, and samples of the other conditions were taken elsewhere. It wouldn't seem so noticeable in the hospital, but when you put them all together and you try and ask a model to train, it's going to find the easiest cheat markers it possibly can. You have to eliminate as many of them as you can, so that it has to learn on the actual important features you're asking it to find. So that's just been a really quick way to at least get an idea that there may be some problem, some kind of bias in the data set that you have. It's generally good to look at as many things in aggregate as you can to do with your data set. So for example, we can look at the estimation that each of the images according to the model is COVID rather than any of the other things. So what we have here is the estimates along the bottom from 0% to 100% certainty that the model thinks an image is COVID. The orange ones are actually COVID, so the ground truth. What we'd hope is that all of the orange ones would be all the way over to the right here and everything else would be over to the left. It's actually not too bad for this COVID one, but if we switch over to, for example, bacterial pneumonia, we see that there's somewhat high certainty for the bacterial pneumonia over here, but there's a lot of bleeding with the viral pneumonia here, essentially showing some uncertainty. This is just a different way of representing a confusion matrix, a slightly more visual way. You can look at this as sort of one column in a confusion matrix. You can do that for any of these. So you can see it does a fairly confident job of distinguishing the healthy ones here from the other ones, as you can see reflected in that cluster map.